So this video I am making to show the general arrangement of switchboard. So this is a switchboard room. This is the switchboard room, and as shown there are 4 generators. So I will show you the switchboard sections one by one, starting from here. This section is for emergency generator. This is the breaker for that. Next, this is harbor generator and the breaker for that. Similarly, there are 4 generators. This section is for DG1, similarly DG2, then this is synchronizing section, and this is the bus tie breaker. This is the synchronizing panel, and this is DG3, and similarly that is for DG4. So I'll show you any one panel of DG, and it is same for all the meters and switches and indicators will be same. So this I am showing you for diesel generator number 3, kVAR meter. That means the reactive power supplied by this generator will be shown here. This is kilowatt meter. As you all know, this is for active power supplied by this generator will be shown here. This is the ammeter. The current supplied by this generator will be shown. Voltmeter. The voltage generated by this generator will be shown here. These generators are rated for 690 volts. 690 volts. This is the frequency meter. Will show the frequency of the generated voltage. The rated is 60 Hz. Next, this is for a selector switch for manual, off and auto. So the operation of this generator, whether it will be on manual or off or auto. So every time, or generally it will be on auto always. If there is some problem and it is not working on auto mode, then it could be shift to manual mode and then tried out, and off during some maintenance or some repair works. This is a selector switch like ammeter. In each phase, RYB or RST we can select. Similarly, the voltage across 3 different phases, RY, YB, BR, and this is the space heater. So during the maintenance of the generators or alternator, this will be switched off and then be opened. Similarly, this is indication to show the breaker is closed, breaker is open, breaker tripped in case of some trouble, some faults, it will trip. Breaker available, engine running or not running, engine available, and engine fault. These are the indications. This is for closing the breaker for DG3 when it is on manual mode. Manual trip. This is to reset in case there is some fault and the breaker is tripped. The engine can be started from here as well in case of manual. Otherwise, in case of auto, it will be started from the engine control room. This is to stop the engine. This is showing panel space heater supply is on. This is a generator voltage control switch. As you can see, it is on off, and one side lower and on the other side raise. That means with the help of this knob we can lower or raise the generated voltage when the generator is on the manual mode, and we can adjust this to adjust this kVAR load, reactive power. If there is unequal load sharing, kVAR load sharing, then with the help of this we can set it to the equal sharing. Similarly, here this is generator speed control switch, same in center, it is off right now. It and on one side lower, on other side raise. That means with the help of this knob we can raise or lower the speed of the engine. This is a Gensys panel when it is on auto mode. So what I was saying, like kVAR load sharing and kilowatt load sharing, or reactive and active load sharing will be done with the help of those knobs. But when it is on auto mode, no need to do anything. It will do all the load sharing automatically by the preset values. And just now, just going down here, this is the breaker. This is an air circuit breaker for DG3, generator number 3. Similarly, we have breaker for other 3 generators also. So in my next video I will be sharing the maintenance of these breakers in detail. So now you saw the control, the panel for DG3. So it is same for 1, 2 and 4. Now we'll come to this section of the main switchboard. In this section, this is control section for bus tie and synchronization, bus coupler and synchronization. So this top part is for synchronization and the lower part is the bus coupler, or also the familiar word for this is bus tie. So in short, here there are 2 buses, bus A, bus B, or maybe port side bus, starboard side bus. Port side bus is supplied by generator number 1 and 2. Starboard side bus bar is supplied by generator number 3 and 4. So again, I am going to share one more video, detailed video about the synchronizing. Here just the familiarization part. So as you all know the basic idea, this panel will be used to connect an incoming alternator with the already running alternator. So that means incoming machine with the connected machine, and that too when the panel is in manual mode. Like here now it is on auto mode, so no need to do here. We have got PMS. So through PMS, just when we start one engine, the alternator will start, the voltage will be developed, and all the required conditions will be matched, fulfilled, and then closed. So in case there is trouble with the auto, we'll have to shift this to the manual mode. When we shift to manual mode, this voltmeter will show the voltage of the bus bar side. So the bus bar side will be supplied by maybe generator number 1, maybe 2, maybe 3, maybe 4, or maybe any 1 or any 2 or any 3. So that voltage which is called as bus side, and the incoming machine or the incoming generator is here. So here it is, so here it is generator side voltmeter. So this is the voltage reading from bus bar side, this is reading from generator side. Similarly, this is the frequency of the bus bar side, and this is the frequency of the incoming machine. So as you all know, there are few conditions to be fulfilled. So voltage should be same, is fulfilled by here, you can watch here, and frequency should be same, that you also see here. And now the very important thing to be matched, that is the phase. The phases of the voltages developed, or the voltage available on the bus bar and the voltage developed by the incoming machines should be same. So this LED will lit when the bus bar is live, and this will lit when the incoming generator is running and it is ready for synchronizing. These are the LEDs which will glow and run either in this direction or in this direction, and that depends on the condition of the incoming machine's frequency. If the incoming machine frequency is fast, it runs in this direction or it rotates in this direction. If the incoming machine speed is slow, it runs in this direction. So basically this is showing the status or the condition of the incoming machine with respect to the connected machine. So as I said before, to adjust. Let's say it is running or it is turning in this clockwise direction, indicating that the incoming machine is fast. But if it is so fast that we are not able to close the breaker, the breaker is to be closed when the Synchroscope is indicating here. So if it is very fast, we will not be able to close, and if it is slow and also turning very fast, we will not be able to close, because we should have some time to close the breaker here. So for that, what we need to do is that adjust the speed of the incoming machine in such a way that if this was rotating very fast and in the clockwise direction, then reduce the speed of the incoming machine. So the rotation will be in faster direction only, but the speed of the rotation will reduce. So it will be like maybe like this, step by step the lights are glowing like this. So when the light this light glows, or when these lights are about to glow, when these lights are about to glow, when these lights are about to glow means when this rotation of glowing of the LEDs in direction of the fast and movement is very slow, and when they are shifting from here to here, okay, in book language it is said when it is shifting from 11 o'clock to 12 o'clock, that is the right moment to close the incoming breaker. So for that, it is very much required that this rotation of these LEDs, okay, not the rotation of the engine. Rotation of the engine should be faster, but the rotation of LEDs should be as slow as possible, so that you will get enough time to close this. Alright, as I said, I am going to share another video on the synchronization. That time I will tell you whether it can be closed when it is running in other direction, that is in when the incoming machine is slow, and so many things related with the paralleling that we will discuss later. Okay, then after that, these are the insulation testers, as I said, bus A or port bus and starboard bus. Here, in case this fails, we have the lamp method also. So these lamp methods will show the condition of the incoming machine, whether the incoming machine is running slower or faster than the connected machine or than the bus bar. And here it is written both the lamps will go dark. That means when you close the incoming machine's breaker, these will go off. So these are the controls for this bus tie or the bus coupler. Breaker closed, that means now the bus tie is closed. This is the push button to close, breaker open, push button to open the breaker or trip the breaker, breaker available, and this is panel space heater. This is the bus bar selection, as I said. Now it is on off, and whenever we want to parallel, so we have to select the incoming machine. So it could be G1 as incoming machine, and the other, any1 or any2 or all the three other than G1 are will be the connected machine. When you select G2, G1, G1, G3 and G4 will be the connected machine. Any1, any2 or all three. BT is the bus tie, and this is G3, and this is the bus coupler. So this is the 690 volt bus section. Now it has got two distribution boards. This is port side distribution, and similarly this is the starboard side distribution. So I'll show you one side, and it is just a mirror copy. Bulk air compressor number 2 on this side, so number 1 is on the other side. This is FIFI pump, that is firefighting pump. Number 2 is this side, number 1 is on other side. Bow thruster number 2, bow thruster number 3, ship service switchboard, that means 690 volt distribution. This is an ROV vessel, so this is starboard side ROV transformer supply. Azimuth, this is azimuth thrusters. This has got electrically operated, I mean electrical motors are used, or this is the electrical propulsion ship. So this is azimuth of one side. Similar on the other side, there are two azimuth thrusters, and this is again distribution of 690 volts. So this is 690 volt distribution. Similarly, this is port side, and this is the distribution. So there are, after this, there are two transformers outside in the engine room, which will be converting this or stepping down this 690 volts down to 440 volt. So here we have one more panel, and this panel is of 440 volts. This also has got two sections, and this is the bus tie. This is the bus tie. Here you can see this is 690 by 440 volt transformer on one side, port side. Supply from 690 440 transformer number 2, starboard side. This is starboard side distribution. This is port side distribution. Now after this 440 volt goes to again two transformers, stepping down to 220, and now here we have this panel as 220 volts panel. So again similar things. This is the bus tie section and all the controls here. There, this is bus bar A, and similarly this is bus bar B. So this is our main switchboard room, in which 690, 440 and 220. This panel I have opened just to show the internal components of DG3, and as I said, it is similar for the others. So this is the one component, DEX, that is digital excitation control system. So this is like kind of AVR, which is for regulating the voltage of the generator. This is a differential relay. This is a differential relay which is specially fitted to protect the alternators for any internal faults that are being developed. This is a Cellco make IO module. All the input and outputs are connected here, and from here it goes to the protection system. This is paralleling relay. So in case of auto, no need to raise or lower either voltage or the speed. This relay will take care, and this will through this control circuit adjust the voltage and the speed to the required level. Required level in the sense, so it will raise or lower and match it with the bus bar frequency and voltage. Then a signal will go to this unit. This is Gensys, and if it is on auto, it will sense all the parameters, and if the situation or if the conditions are fulfilling, it will close the breaker. Now similarly, I am going to show you the internal part of this section of the switchboard. This is control section for bus coupler and synchronization. This is auto synchronizer. As I said, if it is on auto mode, this will check all the conditions which are required to be fulfilled before connecting the incoming machine with the bus bar and give the signal output. This is paralleling relay. This is the short circuit protection. These are the frequency transducers. And these are the protectors here, you can read, and also the percentage volts and percentage in the timing can be selected. So with this I finish this just the familiarization part of the switchboard, and in my next upcoming videos I will show you in detail the maintenance of the breakers and the what you call this Megger testing of the alternator, PI testing, DAR testing, and so many things. Okay, for now, all the best, take care, bye.